Hello and welcome back. Today we are going to discuss about Delta Lake. Now, Delta Lake is getting very popular with lakehouse architecture because it enables you to create lakehouse architecture on top of your data lake. Other than this, Delta Lake has a lot of benefits. So if you go to this homepage of Delta Lake and you scroll down, you can see it has a lot of key features which are not available by default with your big data or the data lake. The first and the most important is ACID transactions. Delta Lake by default support ACID transactions. And the second and the most important is time travel. So in Delta Lake, you can go back in time to see what was your data. And even if you have some issues, you can roll back to that version of that data. The third and the most important is Schema Evolution. It means it will prevent your data from getting corrupted in case of any bad operation. And the final and the most important is DML operations. You can run update or delete queries on top of Delta table, which is not possible by default on a Parquet or a Hive table. Now, other than this, you can see there are multiple more features like scalable metadata, batch and streaming support, open source, audit history. These are all the features that Delta Lake support. And with this supported features, Delta Lake is bringing a lot of difference in the data warehouse structure that you built up on your data lake. And thus, the lakehouse structure is being created. Today, we will see the majority of them with demo. Now, before that, if you have not subscribed to my channel, Ease with Data, I want you to go back to the channel, subscribe my channel, and you can find a lot of playlists based on data engineering. The most popular are Spark Streaming and PySpark Zero to Hero. Go ahead and check them out. For today's session, we are going to use Databricks. Now, Databricks is not free for everyone, but it provides us with Community Edition. You can use Community Edition to run your queries for free. Today, we are going to use Databricks Community Edition in order to try out Delta Lake. Now, Delta Lake is by default supported by Databricks. It is an out-of-box feature that has been provided by Databricks, and Databricks is utilizing Delta Lake for its lakehouse architecture. So, if you have not signed up for Community Edition, you can go ahead and do it. For that, you just need to go to databricks.com and you have to click on this Try Databricks. Once you are on this form, just fill it up, and on the next step, you just click on Community Edition. And once you are done, you will have access to Community Edition. Now, once you have access to Community Edition, to log in, you need to go community.cloud.databricks.com. Once you are on this page, you just need to provide your email ID and password and just click on Sign In. Great, you will see a Databricks workspace available for you. The most important tabs are Workspace and Compute. Now, in order to make your notebooks run, first you need to create a compute. So we will go to this Compute tab and we will click on this Create Compute. Now, by default, Databricks allows you a shared cluster with only one driver of 15.3 GB memory and 2 cores. So just put any name for this cluster. So we'll put Delta Test and we'll click on Create Compute. So once you do this, let me go back to Compute again. You will see a compute being created. While this compute is getting up, let's go ahead and create our first notebook. To do that, I'll click on New and I'll click on Notebook. So I've already created a notebook for me. So I'll just go to my users and my name and I'll click on my notebook. So this is the notebook that we are going to use. Now we have to connect to our compute. So I'll click on this unknown and I'll click on the compute, which is right now starting. So you'll see it is starting. Now, once this is started, we will be able to see a green icon informing us that compute is ready to use. And once that is ready to use, we'll start running our code. So till then, we will wait. Now, if you can see, our compute is up and running. It is a green icon which says Delta Test and it is connected, right? Just to check if it is working fine, I'll just type Spark and I'll run this code. And to run, I'll click on Shift and Enter. Great. Now you see an output here. It means our compute is up and running and our Spark session is also ready. Now, by default, whenever a compute is created and it is attached to your Databricks notebook, it provides you with the Spark session pre-created. So your Spark session object is already created with the name of Spark, and you can go ahead and use this Spark session variable to run your Spark queries. Now, from this output, it is quite visible. The version of Spark is 3.3.2 and we are having a master of local of 8 and app name is Databricks Cell. So this is fine for us. Let's go ahead and see what is the catalog implementation that Databricks provide out of the box. To do that, I have written a spark.conf.get and spark.sql.catalog implementation. So this will provide us the catalog implementation that Databricks support out of the box. So I'll run this. You can see the catalog implementation is Hive. So Delta Lake has a persisted metastore where the implementation is using Hive. So in order to check the catalog, you can just go ahead and run Spark SQL queries. Now, in order to run a query in SQL in a Python notebook, you just need to put %SQL and you can write show databases. And once you do this, it will show us all the databases that are provided using this SQL command. So in order to use a SQL command in Databricks, you just need to use %SQL if you are using a Python notebook. But if you want to use this whole notebook using SQL, you can just go ahead and change it from here. But today we are going to use it as Python. And in order to run a SQL query, we are going to use a magic command called %SQL. So To show the databases that are available in Hive, I'll just run show databases. It will show us the database which is by default present, which is default. Okay, now I have some Parquet data already there in the DBFS location of Databricks. So to show you that data, I'll create a data frame called df sales and I'll read this Parquet data using spark.read.parquet. So I'll run this. Awesome. This data frame is created, right? Now to view the data, I can write df underscore sales dot show. So as soon as I run this, I'll be able to see the data that is present in this sales data dot parquet. Great. You can see the data that is present, right? But Databricks provides us with a very good utility in order to have the data properly formatted. So to do that, I'll just write display and again the data frame name. Okay, this will also do the same work that we are doing using show, but in a neat way. So you can just see it will provide us the results in a beautiful tabular format. Now you see this data. It has provided us the data in a beautiful tabular format. So you can use this display command in Databricks to see any data in a data frame. Okay, so you can see in this data we have 4 columns: transacted at, transaction ID, retail, and description, right? Now we have read this data frame as df sales, right? Let's go ahead and create a Hive table using this data frame. So to do that, I'll write this data in form of Parquet tabular format. Okay, so I'll write df sales dot write dot format, and the underlying format would be Parquet, and I'll put an option which would be the path where I'm going to save this data. So I'm going to save this data is underscore data, and we have it in input, so I'll put it in output, and I'll put it as sales Hive, or say sales Parquet, and we will name it as underscore one just for our satisfaction. Okay, and we will save this table as table. Okay, so I'll name this as sales Parquet. Okay, and I'll just put a mode as override. So if there is any data, it will just overwrite. So I'll put the mode as overwrite. Okay, let's go ahead and run this. Awesome. It completed, right? So our table is ready. Now, before we see the table, let's go ahead and view the files in this location. So I'll just copy this path from here. Now, in order to see the file structure in Databricks file system, you just need to use dbutils command. So that is dbutils dot fs is for file system, and ls is to list the data into that folder structure, right? So I'll just use double quotes and paste this structure here. So I'll run this. Now you can see all the files listed under this. Now if you want to see this again beautifully, just use display. So I'll just use display, and in the end I'll put like this. Okay, I have to change it to display. So I'll rerun. Great. Now you see we have written a Parquet file here. It is under this output folder, right? So this is a Parquet folder structure right now. Okay. Now we can go ahead and check the Hive catalog to see if this table sales Parquet is registered in this database or not. So to do that, I'll just write percentage SQL, and I'll write show tables in default because our database is default, right? So I'll just write show tables in default, and I'll run this. Okay, I have to remove this comment from here, and I'll rerun. Okay, now you can see this is a sales Parquet table which is registered under this Hive database, and this is not a temporary but a permanent table because we have already registered this table as save as table with sales Parquet name, right? So this is already available. Now, if you want to see the metadata of this table, you can just go ahead and use this same SQL command. So I'll use percentage SQL, and I'll write describe, and I'll use this table name. Okay, so I'll use sales Parquet, and I'll run this. So I can see the column names and data type. Now, if you want to see more information about this table, like where it is stored and what is the format of the table, you just need to use extended. So I'll write extended, and I'll again run this command. Okay, now I can see the column names, and if I scroll down, so it just gives me information like it is an external table, it is a Parquet table, again the location where it has been stored. So it is an Hive Parquet table external, right? Because we have supplied the location where we need to save this table. This is not a managed table because we have provided the location. Okay, so this is an external table, but this is a Parquet external table in Hive. It means we will not be able to update or delete any data in this table. So just to show you, let me just run some SQL queries. So I'll write select star from sales default dot sales Parquet. So I'll run this. Okay, you can see this data, right? Let's put out any transaction ID, for example this one. So I'll copy this, and I'll just put where trx id is equals to this id. Okay, I'll run this. So I'm able to see this data, right? You can see the amount is 8.58. Okay, let's go ahead and update this amount. So to do that, I'll write update this set amount is equals to 0, for example. Okay, let's run this. Okay, as soon as I do that, you can see an error here, right? By default, Hive does not support DML operations such as update or delete. Okay, so it is not working for a simple Parquet table which is there in our Hive catalog right now. Okay, now that we know DML operations are not supported for a Parquet table, let's go ahead and write that same sales data in form of delta table. So we have the DF sales data, right? To write it as delta table, I'll again write df sales dot write dot format, and this time in place of Parquet I'll put delta. Okay, and I'll use again the option, and I'll put path where I need to write the data. So we'll write at data slash output, and I'll write it as sales delta underscore 1. So I'll just put 1. Okay, and I'll write save as table because we want to save this as table as well. So I'll write sales delta. Okay, now I'll just put mode as override so that if there is any data it will get overwritten. Okay, so this is okay. Let's run this. Okay, the data is written, right? Now we can go ahead and see the catalog in order to see if the table is registered or not. Okay, to do that I'll put again Spark SQL, and I'll write show tables in default, right? So if I run this, now you can see another table called sales delta. Okay, now in order to see the metadata we can again use describe extended. So to do that I'll write percentage SQL, and I'll write describe extended, which is our sales delta. Okay, I'll run this. Okay, same column names and data type, but this time if I scroll down you can see this is external because we have provided path here, right? But if I scroll down, the provider is delta now because this is a delta table now. Okay, you can see at this path we have saved our delta table. Okay, now they have different properties here. You can see minimum reader version, minimum writer version. So these are different properties that delta live out of the box provides. Okay, so this is our delta table now. Now, what is happening in the path where this table is written? So this table is written at this path, right? So I'll just copy this, and let's go ahead and check the folder structure there. So to do that, I'll write display, and within display we will use our dbutils command. So I'll write dbutils.fs.ls, and I'll put this path. Okay, let me run this. Awesome. Now if you see, it has written the data in Parquet format, but we have one more folder here called delta log. Let's go ahead and check out what is inside this folder. So I'll just put this delta log folder here, and I'll rerun this dbutils command. So if you see, we have some files which are the metadata for delta written here, but the most important is this JSON file. Okay, so delta lake saves its metadata in form of JSON files. Okay, so that it can provide the DML operations or the ACID transactions, the properties it has, right? Audit logs that is being maintained in the form of this JSON files. Okay, so under this folder delta log, it saves all the metadata that is required for its audit log or the time trouble or the DML operations. Okay, so this metadata is something which provides data lake its ability for all the features that you have seen, right? So let's go ahead and check what is inside this particular JSON. Okay, to do that I'll just copy this location. Okay, and again I'll run one more command dbutils.fs.head in order to see what is inside this JSON. Okay, I'll put this. So let me go ahead and copy this JSON file from here, and I'll put it here, and I'll run this. Okay, if I run this you can see a whole lot of things inside this file. Okay, the most important thing is the Parquet files. You can see the path where it is mentioning which Parquet file to read for this particular version. Okay, so this is how it is maintaining all its metadata here. Okay, now that we know what is there inside this JSON file, let's go ahead and see this in form of versions. So to do that I'll just click on code, and I'll write percentage SQL, and I'll write describe history. Okay, for this table which is sales underscore delta. So I'll run this. We'll wait for this to complete. Okay, now this has completed. Okay, let me just expand this here. Okay, now you can see only one version data, which is 0. This is the same information that you get from this JSON file as well. Okay, this is 0th version JSON file, and you have this information here. Okay, now if you see, we have only done one operation, which is create table. So we have just created this table. This is the only operation, and you can get all other metadata informations here. Okay, the most important are the operation metrics. So if I expand this, you can see the number of files that has been written. Only one file, because that is what I've just shown you in this JSON file, right? Only one file has been written. and the number of output rows which is there for the sales data. Okay, now you can see how the version is maintained for delta table. Now that we know about versions, let's go ahead and do some manipulations, which is DML operations, in order to see how the versions are maintained after our DML operation. Okay, so we've already seen the delta JSON, so I'll remove this cell, and we have seen the history for the delta table, so I'll also remove this cell. Okay, let's go ahead and update the data. So I'll just copy the same update command that we have run previously. So I'll copy this, I'll go bottom here again, and I'll paste it here. Okay, and I'll run it now. Okay, so my bad, I've just put it on sales package. Let me just change it to sales delta. So I'll just change it to sales delta and I'll run this. Awesome. Now you can see the number of affected rows because we have only one row for this transaction ID. So only one affected row, right? Let's go ahead and see the data for that particular transaction ID. So I'll just write percentage SQL and I'll copy this from here and I'll write select star from. I'll put it here and I'll remove the set amount. Okay, and I'll run this. Awesome. You can see the amount is set to 0 now. So delta tables support DML operations. Okay. Now let's go ahead and see what is there inside this table now. Okay. In this delta log. Okay. And also in this path where we have our delta tables, right? First, let's go ahead and check the path. So I'll remove this delta log from here and I'll run this. Okay. Now you can see one more Parquet here, right? Let's go ahead and put the delta log and let's run this. If you can see, we have one more JSON here, right? 0001. Okay, this is because we have just made one DML operation, because of which delta table has upgraded this JSON. Okay, so I can just copy this and paste it here. And if I run this, you will see an operation called update is done. Okay, so this is how it maintains. Let's go ahead and see the history. So I'll rerun this history command here. Now, if you see, there's one more version, one created. Okay, and if I scroll to right, you can see the operation is update. And if I scroll more to right, you can see the metrics operation here. So I'll just scroll more. Okay, here you can see the number of removed files and you can see the number of affected rows, which is 1. Okay, this metrics information provides us a lot of information about each version. Okay, so this is maintained in the metadata here. Great. Now that we know how to do DML operations, what are the version informations in Delta Lake, let's go ahead and use the Delta APIs that has been provided for Python for the same operations. Okay, now we will read the delta table using PySpark APIs. Okay, till now we are doing this using SQL. Let's go ahead and read this using data frames. To do that, I'll just write df sales and I'll write delta. And to read the delta table, you can just write spark dot read dot, since we are registering this as table, so you can just write table and we can read sales delta. So I'll just put sales and under this we can write delta. Okay, so if I just use display and I'll write df sales delta, and if I run this, great, you can see the data here, right? Now what if this table is not registered as delta table but has been written at a path? Okay, to do that you can just use format and you can use delta and you can just load it from that location. Okay, so you can just provide the location where we have written this data. So I'll just go ahead and copy this from here. I'll come back and I'll put it here. Okay, so if I run this again, that same output, right? So you are able to load the delta table from the path, plus you can read it directly as table. Now again, you can read a particular version of a table directly as well. So to do that, you can just go ahead and use table and you can put the table name, which is sales underscore delta. So in order to read a particular version, you need to provide the version. Now, if you don't provide the version, whatever is the latest version, that will be read, right? So our latest version is 1, right? But if you want to read the version 0, you can just provide it like this, @v0. So if I run this is the data for version v0. You can also verify, you can just use this transaction ID for which we just changed the amount to 0, right? So you can just go ahead and use this to see if we are reading version 0. So I'll just put where and I'll put it here. I'll remove this here and I'll run this. Awesome. Now if you see, you can see the amount, right? Now I'll just change the version to 1 and I'll run the same command. Okay, the same command, you can see the version as 0, right? So you can read a specific version based on how you read it from the table. Okay, So this is one. Now, what if you want to do it in using SQL queries? You can again do it. So you just need to use percentage SQL here. So to do that, you can just write select star from, and you can use the table name with the version name. So I'll just copy this and I'll paste it here and I'll run this. So it is reading from version 1, right? So just to verify, I'll again use that where command. So I'll just copy this transaction ID and I'll put it here where this, and I'll run this. You can see the amount is 0, right? What if we change it to 0? I run this and you can see it to 8.58, right? So you can read a particular version like this, okay, for SQL queries as well. And this is the benefit that Delta Table provides. You can go back in time and watch the version of data. Let's understand what is schema evaluation. So Delta Tables by default provides you the proper schema as per the metadata, okay? Now, what if I go ahead and add one more column for a particular transaction ID? So it will help us to remodify our whole data set by default, right? So to do that, for example, let's take this transaction ID and I'll add one more column here, okay? So to do that, I'll just make it like this. I'll add one more column called current timestamp as time now. I just need to make it percentage SQL in order to run, and I'll run this. Okay, I just added a new column called time now, right? So in order to make it work, what I'll do is I'll convert this SQL to a data frame and I'll try to add this transaction ID inside this already created delta table, okay? So what I'll do is I'll just create a data frame. So I'll write df new and I'll use spark.sql, and inside this I'll put this whole command, okay? And I'll remove this SQL from top and I'll just display you so that you know what is there inside this data frame. So I'll make df new and I'll run this. Okay, you have this data. Let's go ahead and write this inside the same data frame. To do that, what I'll do is I'll write df new dot write dot format, which is again delta, and the mode would be append because I'll be adding this, right? So I'll just write append and I'll put the option where I'll say merge schema as to. It means please add this in the same schema but merge it. Add the new column to the existing schema, okay? And I'll say option and again I'll put the same path and load, right? So I'll just copy it from the top. I'll just go here and I'll copy this whole thing and I'll come to bottom and I'll paste it here, okay? And I'll run this. So I have just made a mistake here. I'll make it append and I'll rerun this. Okay, sorry, my bad. The option is merge schema, so I just missed the A here, okay? I'll run this. Okay, now it has completed successfully. Let's go ahead and check the version. So I'll just come back here in the top, okay, and I'll run this describe history. Now you can see there is one write operation because we added, right? So let's go ahead and see the data. So to do that, I'll just come here and I'll run this from the same data table. You can see the time now. For the old record, it was 0 and we just added one record here, right? That was with the timestamp. Now if I remove this, you can see the time now column added for all the records. Okay, so if I scroll to right, you can see the time now is null for all the records. So delta table has by default managed that schema. Okay, whatever the new column that we added, it has been added for all the records, right? So it has managed that schema evolution by default. Okay, so that is what is one more benefit that delta table provides. Now in case of Parquet, you have to rewrite the whole data adding that column. That's the problem that we have with Parquet and Hive table. Okay, but in delta table you just use this merge schema option and you append the new record with the new columns. Delta table will by default take care of all the rest of the records. Now, delta table also provides us libraries in Python that we can use to manipulate delta tables. Okay. Now, so from delta, you can import this delta table command. Okay. Now, to read a delta table by name, you can use the Spark session. I'll just use DT, which would be my delta table, and I'll write delta table dot. I'll use for name because we have created table with name, right? We'll use the Spark session, which is Spark, and we will use the delta table name, which is sales underscore delta. Okay. And if I run dt dot, and I just want to show you the history, so I'll just type history, and if I run this, you can see it has created a data frame. Okay, so to see a data frame in a proper way, you can either use show or display. Okay, let's use show here. Now you can see the all information about the history, okay, using delta table APIs. Okay, now if you want to see this beautifully, you can just use display command, right? So I just write display and I'll just rerun this. Okay, now you can see the same version information here, right? That has been provided. So now let's go ahead and convert an existing Parquet table into Delta table. Okay, Delta table libraries provide us with that information. Now, first let's go ahead and check if that particular location is a Delta table or not. To do that, you can just write Delta table dot is Delta table. Okay, and now you have to provide two options. The first one is Spark session, so you can just write Spark, and the second is the location. Okay, so let's just go ahead and paste that location where we have our data. So I'll just write data slash output slash sales Parquet underscore one. Okay, let me just run this, and you can see it says false, means it's not a delta table. Okay, let's verify our delta table. So I'll just remove this Parquet and I'll write delta, and I'll run this. It says true, it means it's a delta table. Okay, what if I want to convert my Parquet table, which is at this location, to delta table? Okay, so this is at this location, right? But this is not a delta table. I want to convert this. To do that, I can just use delta table dot convert to delta. We have to provide the Spark sessions. All right, Spark, and we have to provide the option as Parquet. So I have to write Parquet dot, and then we have to provide our location. Okay, in tick mark. So you can see this is tick. I have put it as tick. So I'll just put it here, and I'll change it to Parquet. Okay, and I'll run this. Awesome, it has completed, right? Let's go ahead and validate this location. So I'll just use display and dbutils.fs.ls, and I'll put this location and I'll run this. Okay, now if you see, we have delta log here. It means it's a delta table now, okay, as per the path. But if we try to check our metadata now, so I'll use percentage SQL, and I'll write describe extended and sales Parquet, and if I run this, if I scroll here, you can see still Parquet, okay, because the metadata is not updated. We have written a delta log here in order to convert it to delta table, but we have not updated our metadata. To do that, I'll change it to percentage SQL, and I'll write convert to delta and the table name, which is sales dot Parquet, and I'll run this. Okay, sorry, my bad, it's sales underscore Parquet. Okay, let me run this. Awesome, it says okay. Let's go ahead and again see the metadata for this table. So I'll run this. Now if I scroll down, you can see this has changed to delta. Okay, now we have successfully converted our Parquet table to delta. Awesome. Now one more thing. So we are reading particular versions of data, right? So we were reading particular versions of data here using SQL commands, right? V0, V1. What if we want to revert back to a particular version? For example, if you see the version for this table, delta table right now, it is 2, right? What if I want to revert back to 1? Can we do that? The answer is yes. So to revert back, you can use SQL queries. You can write SQL restore table, and the name of the table, which is sales delta to version as of, and the version number. For example, we want to go to 1. Okay, so let me run this. If you see, we have updated the version. Let's go ahead and verify. To do that, I'll use the percentage SQL, and I'll write describe history of sales delta. I'll run this. Okay, now you see one more version here. It says restore. So we are restoring one more version here, right? So if you want to see the data, you can just go ahead and write select star from the sales data, and I'll use the same transaction ID. Okay, last time we had 2 records for that because we just added 1, right? So I'll just use this, and I'll place it here, and I'll run this. Okay, you can see the amount as 0. What if you want to see the older version? You can use it, right? V2. So if I run this, this was the version V2 which we have for which we had 2 records, right? So we have restored to version 1. Okay, so the version 1 is right now this value, right, which we have for our default version 3. Okay, which we have restored, okay, which is 0 again. So this is how you can revert back to a particular version. Okay, now if you go back to the same location again, to the of the delta table, so I'll just go back to the location here, and I'll remove the delta log, and I'll run this. Okay, you can see so many Parquet files being written, because every time when you manipulate a version, delta table tries to rewrite a different version of data in different Parquet files in order to maintain that time travel, right? Now consider you are writing 200, 250, 300 versions, so will have a lot of data here, right? And that's not wise. You have to clean it up, and in order to do that, delta tables provide us with an option called vacuum. Now to do that, you first have to read it in form of delta table. So I'll read as delta table dot for name, and I'll write Spark, and the name of the table is sales delta, right? And to do vacuum, we'll remove all the unnecessary versions now. So I'll run this. So you can see it says there's a retention period that has been provided. Now for your delta table, if you set it to 0, that will create some problem, and that default retention lock can be removed using this Spark configuration. You have to set spark.databricks.delta retention duration check enabled as false. So this time it will not check the default retention duration, rather whatever is the data, it will manage it. Let's go and do this. So this vacuum operation has now removed your all older versions, and you will have your latest version as the latest one. Okay, just to verify if you have the data removed, so I'll just use the dbutil command for that Spark delta location. Okay, so I'll just go ahead and run this. Now if you see, you have only one Parquet file, and all other unnecessary Parquet files are removed. So what happens to the metadata? Let's go ahead and verify. To do that, I'll write describe history, and I'll put the sales delta table here, and I'll run this. Now you can see the versions are still available, right? 3210. Let's go ahead and see the data to understand what has happened. Okay, so I'll just write select star from, and by default this is the version 3, right? And I'll put the where condition in order to see the changes in the transaction ID. Okay, so I'll run this. You can see the amount as 0. Okay, now for V2, if you remember, we had 2 records, right? So if I run this, you are not able to see the V2. Okay, because there was data which is now removed because we have vacuumed, right? Now if I try to make it V0, and if I try to run it, you can see the same error, right? Because Spark has removed all the older files. Okay, the versions are still there, but you will not be able to access. The time travel is now not possible because you have vacuumed the data. And that is why vacuum is a very important operation that you have to do carefully, because if you want to retain up to some versions, you have to be very carefully doing the vacuum for that particular time. Okay, you cannot just go ahead and make it as vacuum 0. In vacuum 0, it would remove all the time travel information, and only the latest would be preserved. Okay, so this is very important. Now, the last operation is converting to Parquet. What if I want to convert a delta table to Parquet table? Is it possible? The answer is yes. And we have already covered a lot of things in order to answer this question. Now, I want you people to try it out. Now, I'll be posting the answer of this question in the comments, but please go ahead and try this out. How to convert a delta table to Parquet. Okay. This was all for today. Now, we have learned a lot of things about delta, and this is very important to get you started with delta tables. Now, if you want to play around with delta tables, I would recommend you just go ahead and subscribe to community edition of Databricks and try it out. Now, if you like my content, please make sure to put down your valuable feedback in comments, and please like and subscribe my channel. Now, in our next video, we are going to check out some optimization techniques that are available for delta tables. Till then, keep learning, keep sharing, keep growing.